Hey everybody, this is Garrett with Earth and Time, and today I'm coming to you from one of the most volcanically active areas in the United States of America. It's not the Cascade Range, it's not Yellowstone, it's actually the Long Valley Caldera complex on the eastern side of the Sierra Nevada mountains in California and Nevada. Today I'm going to start this adventure here at Hot Creek Geological Site, and we'll talk a bit about the volcanism in the area, talk about some of the rocks here, and then through the course of this video we're going to visit a number of other sites around the greater Mammoth Creek and Mammoth Lakes area. So with that being said, let's get to it. Welcome to Hot Creek Geological Site, just outside of Mammoth Lakes, California. And what's fascinating about this site is we're actually sitting on top of a volcanic dome that has slowly risen up, and the stream is actually cut through it, creating this amazing topography and this beautiful canyon. Now, as I'm standing here, we can see off in the distance there's some hills in that direction. We can't quite see the hills so well off towards the west, but we're sitting pretty close to the center portion of what's known as the Long Valley Caldera complex that erupted in a massive way, basically like a super volcano. And the caldera itself is about 10 miles long, about 10 miles wide, 8 miles wide or so, and occupies a big portion of this region. Now, I have heard it's up to 20 miles wide as well, and so we'll try to check on that and see if there's more information as we continue. So why I want to bring you all here is that there's actually active hot springs here that are so hot, up to 400 degrees Fahrenheit, that you actually can't get into them because magma has gotten so close to the surface here that it's actually heating up the groundwater and coming out and feeding into this stream known as Hot Creek. And we can actually see those hot springs and fumaroles straight ahead of us. Now, as I'm walking down to the hot springs, you'll notice there's a bunch of really beaten up looking rock here. So this is all rhyolite from that volcanic eruption 700,000 plus years ago, and it's known as the Bishop Tuff. And normally it's kind of more of a buff or tan color, but because it sits so close to the hot springs down here, that it's actually been altered. So the hot water comes up along fractures and faults here, being fed by the magma chamber beneath our feet. And that starts changing the colors of the rocks here, which were once more of a buff color. In fact, we can really see that relationship straight across from us over here, where you can see that where it's been altered white compared to the original rock around it. Now, the water here is scalding, and there have been deaths associated with individuals either falling into the hot springs or unstable ground, falling into the hot water, as well as folks that just got in thinking, oh, this is a regular hot spring, and of course, didn't live to tell about it. Here's a view where we can really see the modern hot spring coming up. You'll see it has that blue-ish color to it, and that's because the minerals that are associated with it. A lot of times, calcium carbonate limestone creates this amazing blue color, and that's why you see those blue bays and areas along the ocean associated with calcium carbonate. It really creates that beautiful blue color, and it's the same here, even along this hot spring. So many interesting geologic things to see as you go on this walk down to Hot Springs Geological Site, but you can actually see the flow banding from the edge of the caldera here, and look at those flows coming through. So these are rhyolite flows, so these are very viscous. And these wouldn't have traveled as far as, say, the types of lava flows we think about in places like Hawaii. These would have been much more localized. And so this is kind of a classic rhyolite flow, which often happens late stage and or early stage within one of these caldera stories. So now I've moved a little closer to where the hot springs are over there. And what I want to point out without getting too close is you can actually see where gas is coming up along the river here. Now, I don't know if that's boiling. I can definitely smell some sulfur, but you get an idea about how active this area is and why it's called Hot Creek. And there's effervescing or bubbles coming up all along the edge of the stream here. So what kind of gases could be coming up out of here? Well, there's a lot of CO2 in this area, as well as you'd end up having things maybe like sulfur dioxide coming up, which is what gives us that rotten egg smell, which we can definitely smell throughout this valley. The other thing I want to point out here is from where you can actually see the hot springs across the way. So that's where the hot springs currently are, but we can actually see evidence of ancient hot springs here as well, actually right where I'm standing. And we can see those right here. And these are actually what people often call tufas or travertine mounds, and they're just calcium carbonate, much like you think of limestone. It's the exact same material, but it forms along hot springs. And we can see this is where one of the hot springs used to be at, is now long dead. And we can actually maybe even see down to where maybe the fumarole was down in this hole here. But this gives you an idea that these hot springs don't stay in the same spot all the time. They actually move throughout time. Here's another view looking at where the current hot springs are located at, and you can see the rocks across the way are actually made up of what we call a breccia. A breccia is basically a bunch of material that's been ground past each other, and or you can think of it like a volcanic eruption which jumbles all the rocks together, and that's exactly what we're seeing here. So as I walk along this creek, this whole area is slowly being risen up because there's still a magma chamber underneath where we're walking today. And this river was established before that magma chamber started rising again after that eruption over 700,000 years ago. So what's happening is this river slowly eroding through this topography, through the old volcanic debris of ash and rocks, and it's continuing to establish its pathway. But as it erodes through, it means that one, it's adding water closer to the magma chamber, so we get things like hot springs, and two, it's allowing for this amazing topography and scenery here that is the Hot Creek geological site. And I've mentioned that the spring hasn't stayed in the same location. It's actually moved around. So these hot springs can form, and then as they deposit material, as they're forming, they eventually clog themselves up. So the springs can no longer bring the hot water to the surface, so they move somewhere else. And we can actually see where this last hot spring most likely was. And I can see that right here, where I can see the travertine formed by hot springs. In fact, can you see how these are vertical? You can really see where the conduits were for the old hot spring here until it finally choked itself out with mineralization. And in this case, it's a calcium carbonate in here, which creates these amazing designs. The other thing to notice is the color. Notice how white these travertines are in old hot springs deposits. Look at these ones. They're much more buff colored, more gray, a lot more weathered, suggesting these are much older hot springs deposits. So as geoscientists, we can look for clues like that. What are the color of the rocks? What do we think's happened through this area to get an idea about timing and how something like these hot springs have moved throughout the history of this canyon. Now, these were all probably forming and getting clogged up over thousands of years, maybe even less, because of the amount of precipitation that takes place along these hot springs. But what it means is that we can put together a bit of a story here about, we know we're underneath a magma chamber inside of an old caldera that's still active because we still see the hot springs. We know the hot springs are migrating and the river is continuing to cut down through as this magma chamber is slowly risen. Pretty cool story, an amazing place to come look at. Hoping the caldera doesn't decide to get grumpy and start exploding today while I'm sitting here, because if it does, well, we're all in trouble. So as I'm walking up, I do want to point out one more geologic feature here, and this is pretty interesting. If we look on the right-hand side, we see more intact rock, still pretty beaten up, but on this left-hand side, it's what we call a breccia. So one of two things is happening here. Either this is debris from the volcanic explosion here settling in, or the interpretation I like a little bit more is there's a fault running right through here from the right-hand side where we can see the more intact, still beaten up rock, to the left-hand side where we see this white rock with the large gravels in it. So it could be a combination of both volcanic activity and potentially a fault in here. We know there are faults associated with this caldera. So now I move my way back on top of the canyon, and what I want to point out are, if I go from the hot springs down below and I look up, all those hills you see out there in the foreground are all part of this resurgent dome of the Long Valley Caldera. In fact, if I pan way to my left, You can see one edge of the caldera there towards Mammoth Lake. And if I pan to the right, you'll see the other side of the caldera off to the east and the mountains there. And they have this really nice display showing what the geology here looks like. So they talk about the fact that we're between these two mountains, Sierra Nevada mountains and Glass Mountains, and there's a series of faults that help feed up the hot water. And I think we saw potentially one of those faults or an exposed version of one of those faults that's bringing up the hot water. But we can also see where they're talking about having, or where the magma chamber resides deeper underneath us. Really nice display. And if it's your first time coming out here or just coming out here in general, this is a great spot to take a look. And I will say, they did say it's 10 by 18 mile depression associated with this volcanic eruption. And it says 700,000 years ago. I've read closer to 760,000 years ago, but what's 60,000 years amongst friends? All right, so let's go head up to Mammoth Lake area and let's go take a look at some of the unique volcanic features or evidence of volcanism that are up there. All right, everybody, welcome to Mammoth Lakes, California. Now, I'm sitting in front of the Mammoth Dome here, and if you look behind me, you'll notice there's a whole bunch of dead trees here. And the reason I wanted to come here to talk about volcanism is for two reasons. One, because we have a resurgent dome behind us, this big, I believe it's a rhyolite dome here at the edge of this Long Valley Caldera complex. And two, some really interesting things happened here in the 1980s. In 1980, they started picking up a lot of seismic activity in this basin and believed that to be related to the movement of magma at depth. And they actually thought an eruption was going to occur. Now, an eruption didn't occur, but then again, in 1989, there were some more earthquakes and seismic activity in the area. And the result of that are these trees that you see dead around us today. Back in 1988, this was a healthy forest, but in 1989, with the seismic activity here and the activity with the magma, it brought up a lot of carbon dioxide and actually suffocated the trees here. In fact, they still have these signs up talking about the natural toxic gas here due to that event in 1989. Now, as I pan through here, it's very post-apocalyptic, and you can see how the CO2 got in the soil and actually suffocated all of these trees. These are not small trees, and it is a weird, surreal feeling standing somewhere you know where a volcano can erupt at any time. And it's a volcano that most people don't really think about, or I think know about, unless you live in this part of the United States. The fact that we're sitting on top of such an active caldera, one that's probably second only to the Yellowstone hotspot if it were to erupt. So this would be what would be known as a supervolcano if that did indeed happen. And when it happened in the past, they actually found ash all the way out to Omaha or out to Nebraska and Kansas from this eruption, to give you an idea about how major of an event this would be if this were to explode. So I've walked up from the lake a little ways, and what's fascinating is there's this old cabin, some kind of feature here, maybe a ranger cabin that sits in the middle of all these dead trees from that event in 1989. We can also see some large boulders of granite here, which are known as erratics, or chunks that have been left by the last glacier that went through here as well. When I stand here for scale, you can see some of these boulders are very large behind me, but you also get an idea about the sheer area and volume of trees that were killed in this event. All right, so from here at Horseshoe Lake, looking at this death zone for the pine trees in this area, here's taking one more pan around, looking at Horseshoe Lake and all the dead trees. By the way, what do you call dead trees? They're actually called snags. So there's your trivia today from Earth and Time. And I can't get over how haunting it is having this little barn feature, old ranger cabin in the middle of all these trees and death. And we'll end this by looking at the mountain that is now resurging with magma straight in front of us. Okay folks, now we've moved our way to Devil's Postpile Trailhead, which was about, I don't know, about 35-40 minutes away from Horseshoe Lake. And now we're in a glacial valley here that at one point was actually dammed, and a volcanic flow came down and it ended up creating a lava lake, which is what we're going to go see are the remnants of that. And to do that, they actually have this nice display showing how originally there was a volcano that erupted just up the valley from us. As the magma flowed down, it got ponded up inside of a glacial valley where there was a series of moraines that actually stopped the flow of the lava. And once it stopped, it slowly cooled, and with that slow cooling, you ended up getting something like these columnar basalts. And from this vantage point, you can really see the columnar basalt known as the Devil's Postpile. Now we can take a closer look at these basalts, and one thing to pay attention to is how, if you look on the right hand side, you can see how they're all vertical, which is pretty typical for columnar basalts. However, as we move off to the left here, you can see how they're starting to bend over, and that's a result of where this is being deposited at. And what happened here is as this lava lake was forming and things were starting to cool here, you're actually up against the edge of the glacial valley, and there's just a little bit of flow and warping of these columnar basalts as they're starting to crystallize, or of the lava, the molten lava, as they're starting to crystallize, creating these amazing shapes, and pretty unique. I've never seen shapes like this anywhere else. So one last thing to say about this lava flow is about 100,000 years old. Glaciers have been coming and carving down this side of the Sierra Nevada mountains for hundreds of thousands of years. This glacier came through, carved this valley, and then there's eruption off of Mammoth Mountain. So more evidence here of fairly recent volcanism within the last 100,000 years, and spectacular shapes. So one of the things they've done is I work my way to the top of the basalt flow in the columns. Is they've actually made steps out of each of the columns. It's pretty cool. So as I work my way on top of the columnar basalts, you can really see this glacial valley now and see where glaciers probably came from both directions here towards the north, as well as from this direction as well, kind of that northwest way, and glaciers would have carved right down this valley hundreds of thousands of years ago, all the way up to 10 to 15,000 years ago. And another view of this glacial valley, and where you can see the granite on the other side. Now again, that granite here is Jurassic in age, so from the middle time of the dinosaurs, and is part of the Sierra Nevada batholith. All right folks, so we made it on top of the columnar basalts, and I hope you all can notice right away how they're in these hexagonal patterns. And that's a result of how they cooled. Really neat. And the other thing you can see on here are these striae. This is from where a glacier went across. So all those marks you see is because a glacier went across the top of this and scoured it, creating basically the equivalent of skid marks. And we call them slicken lines in geology. And so you can see my hand for scale, how big these columns are, right? So, not quite a meter across, maybe a foot and a half or so across. But what's fascinating is you can pick up a whole nother story of what's happening here. So not just this old lava lake, but you can also see where a glacier came through later on and scoured this. Really cool to see, and a fascinating story. From the columnar basalts here, we can look up and see, going down the valley, where this lava lake would have continued. Now, a lot of it's gone because there's been later glaciation here, as recently as around 10,000 years and maybe even 8,000 years ago at this high altitude. But what we can see still that's left over are these basalts that we're staying on top of. Really amazing place to come visit if you come to Mammoth Lakes. Thank you all for joining me today to check out the volcanic story here around Mammoth Lakes, California. It's pretty fascinating. It really is one of both volcanism and of glaciation, really a story of fire and ice up here. If you enjoyed this episode, please remember to subscribe to my channel, Earth and Time. And if you like this video, please give it a thumbs up and please leave comments down below asking about geology, asking about history. I love that y'all join me for these adventures and we can all learn together. So with that being said, thank y'all for joining me. See you on the next adventure and take care.